Boys and girls, meteorologist Steve Caparata back with another episode of Cap's Corner Summer Camp. This week we're going to talk all about hurricanes. We're into hurricane season now, so it feels like a good time to talk about it, doesn't it? All right, let's talk a little bit about some hurricane basics. So I mentioned we're in hurricane season right now. Hurricane season where we live for the Atlantic Ocean, the Gulf of Mexico, officially runs from June 1st, the beginning of June, through the end of November, November 30th. Why is that? Well, those are the months where the ocean, the Gulf of Mexico, is typically warm enough to support a hurricane. We're going to talk more about the importance of that warm water coming up in just a moment. Now, where we live in the northern hemisphere, which is north of the equator, if you want to go look at that on a globe, if you have one at home, our hurricanes spin counterclockwise. So that means opposite of the way the hands usually spin on a clock, counterclockwise. That's how our hurricanes spin. Now, if you go south of the equator, they spin clockwise. Kind of confusing, right? But where we live, counterclockwise. Now, there are other names for hurricanes you might hear about. Typhoons, you might hear about cyclones, but they're all the same thing. Hurricanes, typhoons, cyclones, just different parts of the world call them by different names. So hurricanes, typhoons, cyclones, don't let that throw you off. It's all the same thing. All right, so if we were to get into, say, a weather kitchen and try to put a hurricane together, we need some building blocks first. So you boys and girls, you might play with Legos at home. And if you want to build something in particular with your Legos, there are some certain pieces you might need, right? Well, if you want to build a hurricane, first off, we have to start with a cluster of thunderstorms. That's the very first important ingredient. Next, that cluster of storms can't be too close to the equator. I'll show you why that is in just a moment. And then the third thing is we need what is called low wind shear. We're also going to talk more about wind shear in a moment, but basically wind shear is what rips storms apart. If it's too strong, it rips storms apart. So hurricanes don't like wind shear. Once we have the building blocks and you maybe have something beginning to develop, here's what can fuel a hurricane. We want warm water. Generally speaking, that water to be at least 80 degrees warm. We want the atmosphere to be unstable. And simply put, that means that the temperature down at the surface is warm, and as you get higher up in the sky, temperatures get cooler the higher up you get. And we also want to have plenty of moisture, not only down at the ocean surface, but higher up in the atmosphere as well. So let's look at that in a little more detail, how we can actually make a hurricane develop out over the ocean. So we start out with the sun heating the ocean up, heating things up. And what does that do? That causes evaporation. Now, coming up in a future lesson, we'll talk more about the water cycle, but evaporation is when we change water from a liquid to a gas, and that becomes water vapor. It rises up into the sky as long as the atmosphere is unstable. Remember, that means we've got warm air down at the surface getting cooler as you go higher up. Once we get that evaporation, that water vapor rising up into the sky and it cools, it then undergoes condensation, where it changes back from a gas to a liquid, from water vapor back to drops of water. We get our storms developing. This leads to what we call convection, or big clusters of storms. The next step in the process here is that we've got to make sure not only is it kind of moist down here at the surface of the ocean, but the atmosphere above can't be too dry either. We need it to be moist up above. Again, that wind shear needs to be low. If there's too much wind shear, as these storms try to grow, they'll get toppled over and they won't be able to stay together and organize into a tropical storm or hurricane. We talked about the warm water, right? We want that water, generally speaking, to be at least 80 degrees. All right, now let's see how this all plays out through time. So once you've got all those ingredients together and low pressure starts to organize, remember, if you were with me last week, I told you a little bit about low pressure. Once low pressure organizes and we start to get these clusters of storms rotating a bit, but the winds are less than 39 miles per hour, we call that a tropical depression. Now, once those winds increase a bit to at least 39 miles per hour, but less than 74 miles per hour, it becomes a tropical storm. It's at that point that it gets a name, and we'll talk more about names in a moment. And if those winds get up to at least 74 miles per hour, that's when it becomes a hurricane. All right, let's talk about how we rank our hurricanes, or how we rate them. There's something called the Saffer-Simpson scale. And it's kind of a goofy sounding name, right? Well, where does it come from? Well, it's actually named after the two gentlemen that created it. But very simply, the Saffer-Simpson scale tells us how strong a hurricane is based on how high the wind speeds are. So it's a scale that goes from 1 to 5. A Category 1 hurricane is the weakest, if you will, has winds anywhere from 74 to 95 miles per hour, and it goes up to a Category 5. A Category 5 hurricane, very powerful, has winds of at least 157 miles per hour. And then if you watch the news, if you watch us do the weather, you might hear us talk about something called a major hurricane. What is a major hurricane? That's anyone that's a Category 3, a 4, or a 5. Those major hurricanes are the ones that do the most damage. All right, we're going to now take you into my home lab before we get to this and talk a little more about what storm surge is. But I want to talk about how hurricanes, not only how they get the winds, but once that wind is kind of blowing a little bit, how the winds start to get stronger and stronger in the hurricane. So let's go into my home lab, check that out, do a little experiment, and then we'll come back here to talk about storm surge. All right, boys and girls, back in the home lab now, and I told you I would explain why hurricane winds blow so fast. So hurricanes spin, right? Well, anything that spins, it has something called angular momentum. Now, the way you would most often see this shown is with an ice skater, with a man or a woman has his arms out, brings them in tight, they start spinning faster and faster. Instead of that, guess what? It's like 100 degrees outside, so we can't do ice skating. We brought it inside, so you need a stool that spins and a couple of weights. So make sure you check with mom and dad on this. Eliana's got a couple of 3-pound weights. She's going to extend her arms out. Put your arms out, Eliana, with those weights, and I'm going to give her a good spin. Here we go. Now pull them in. Now let them out. And she stopped. All right, did you guys see that? So, Eliana, what happened when you pulled them in? What happened?
I spun faster.
You spun faster, and then when she pulled them out, she kind of came to a stop. That's all about that angular momentum. That is the same thing that's happening in a hurricane. Another way you might see us talk about this on the news sometimes, talk about the eye of the hurricane, the center. This actually goes against what a lot of people think. When the eye is bigger, usually the winds aren't quite as strong. If that eye starts getting smaller and contracting, as we say, the winds start getting stronger. That's more of that angular momentum. So try that out at home. Let me know if it works for you guys. All right, did you guys get the chance to try that out at home? Hopefully you get to see how the winds can really start to spin faster and faster in a hurricane after doing that, if you get a chance to try it out, that is. All right, so winds are one part of a hurricane. There's a lot of water that comes with a hurricane too. Not only the rainfall, but something that's called storm surge. So what is storm surge? Well, as a hurricane moves towards land, this is the coast right here. It's pushing, all that wind is pushing the water along. And as the water starts to hit up against the coast, and the coast usually has some slope to it, as it starts to get pushed into the coast, it starts to pile up. That wind-driven water from the hurricane that piles up along the coastline, that's what we call storm surge. And depending on how strong the hurricane winds are, how big the hurricane is in size, and some other factors, that will tell us how high this storm surge gets. Now get this, in Hurricane Katrina in 2005, long before most of you guys were born, but it was a really bad hurricane that hit Louisiana and Mississippi, and parts of Mississippi. That storm surge was nearly 30 feet high, if you can imagine that. That's almost the height of a 3-story building. So hurricanes can really pile a lot of water along the coast and then push it inland. All right, so I mentioned to you a moment ago, we can't have hurricanes develop too close to the equator. Let me try and explain why that is to you. So this map here, boy, this is kind of confusing, right, boys and girls? What is Mr. Steve showing us right now? Well, all these lines, these are all the tracks of the hurricanes, the typhoons, the cyclones around the globe that we've seen over the course of about 160 years that we've been able to track. Now, let me paint in for you this blue line. That's the equator. So again, remember the equator kind of divides the earth in half. So we live north of the equator in the northern hemisphere. Louisiana is right about in there if you can make it out on the map. And then south of the equator, that's the southern hemisphere. I've highlighted this area in yellow though. If you look closely in that area of yellow, watch as I zoom this in. We don't see any of these lines. We don't see any of these storm tracks close to the equator, right? You have to get a little bit away from the equator to actually see any tropical storms or hurricanes develop. So why is that? Well, let's talk about something called the Coriolis Effect. All right, we're getting into the science. You say, Mr. Steve, I don't know if I can handle this. Let's see if we can break it down. So a hurricane, again, back to last week's lesson, a hurricane is an area of low pressure. In low pressure, one thing we know is that the winds blow towards the center of low pressure. I'm going to let this cycle back again. We're going to run through this animation. So in low pressure, the winds, watch, they come towards the center, toward the eye of the hurricane. However, since the earth we live on rotates, those winds get deflected to the right. That's called the Coriolis effect. And so instead of blowing straight into the center of the storm, that deflection causes this spinning, this rotation around the eye of the storm, around the eye of the hurricane. So if the earth wasn't spinning on its axis, the winds would go straight into the center of the hurricane. But since we have a spinning hurricane on a spinning earth, you get kind of some crazy stuff happening. It's called the Coriolis effect. I know that's a little bit confusing, so let's do this. Let's go back into my home lab, and I'm going to show you a little experiment how you can kind of put the Coriolis effect in or see it in real life. So let's go check that out. All right, boys and girls, back in the home lab. So it's just trying to show you how the Coriolis effect is what kind of makes the wind spin around the hurricane. So here's how you can kind of see it in action at home. I got a balloon, I got a marker. Make sure you work with mom and dad on this. Be careful with the Sharpies and the permanent markers, all right? So we drew on here a dotted line to kind of pretend that's the equator. North of it's the northern hemisphere, south of it the southern hemisphere. We drew an N on top for the North Pole, an S on the bottom for the South Pole. And what I'm gonna do is I'm gonna spin this. Clara's gonna start trying to draw a straight line from the North Pole as I spin this. Yes, get up a little bit higher and all right, you go ahead. Start drawing. All right, that's good. Now draw your arrow on there like you were going to do. Boom, right there. That's good. So what you're going to see when I show you here in a second, you see how everything bends to the right? So that's what happened with the winds. The winds are trying to blow straight into an area of low pressure, but because the earth spins, they end up getting bent to the right, north of the equator. Now what Eliana's going to do here is show us what happens in the southern hemisphere. All right, you ready? All right, draw your arrow on there. So that one bent to the left, right? So the deflection or the bend south of the equator in the southern hemisphere is to the left. And this difference on either side of the equator is why our hurricanes spin counterclockwise. But believe it or not, south of the equator, they spin the opposite way. So this spin that we get in our hurricanes, the Coriolis effect, it's all about the fact that the earth spins on its axis. So give this a try at home, and hopefully you can see how it works. So how about that, boys and girls? I think that's kind of a cool way to see that Coriolis effect. I know it was probably a little bit confusing, my explanation at first, so hopefully that experiment, and if you get the chance to try it out, helps it make a little more sense. All right, so we talked about the importance of warm water for hurricanes, right? One thing we know closer to where we live, so I've put Baton Rouge on the map. This is called the Gulf of Mexico. One thing we know is that throughout the summer and really most of hurricane season, the waters of the Gulf of Mexico are warm enough to to support tropical storms and hurricanes. That means at least 80 degrees. You can see how warm some of these temperatures already are. Mid to upper 80s, it's plenty warm. One thing that can happen with hurricanes, though, because they have so much wind with them, as a hurricane moves over the ocean, that wind starts to stir up the ocean. And while the very top of the ocean is typically pretty warm this time of year, believe it or not, if you were actually able to go out farther into the Gulf of Mexico, out in the middle of the Gulf of Mexico, and go for a deep dive, a deep swim, we're not going to do that. But if you were able to do that, once you got below the surface deep enough, you would notice the water getting colder and colder. Well, as a hurricane moves over that water and all that wind blows and stirs it up, that can start to pull some of that cold water up from below. And what happens? A hurricane doesn't like that. So if it starts to pull up too much of that cold water from below, we call that upwelling. That can cause the hurricane to start weakening. But there's something in the Gulf of Mexico that can kind of fight back against that. It's called the loop current. So maybe some of you, depending on where you are in school, how old you are, you might have heard of the Gulf Stream. The Gulf Stream is very warm water along the east coast of the United States. What you probably haven't heard of is the loop current. So the loop current is a current of warm water that runs from the Western Caribbean, just west of Cuba, up into the Gulf of Mexico, loops around, that's where it gets its name from, goes through the Florida Straits to south of Florida, and actually links up with the Gulf Stream over here. But why is the loop current important? Not only is it warm water, it is very deep warm water. We're talking about water that is warm enough to support a hurricane that goes several hundred feet below the surface of the ocean. So if a hurricane moves over this loop current and it's stirring up the ocean, it doesn't matter. It's just pulling up more warm water. It's an endless supply of fuel. So this has happened with several storms before. It happened last year. This is a look at Hurricane Ida. And basically where you see the oranges, the reds, that is representative of the loop current. And you can see here, these little yellow triangles, that's the track of Ida. Notice how Ida tracked right over the loop current. So not only was Ida moving over some warm water, it was moving over some very deep warm water for much of its path before it hit Louisiana. And that, unfortunately, was one of the things that made it such a powerful hurricane as it approached the coast. Now, it's important to remember the ocean is just part of the equation. You need warm water, but we need those other things we talked about. We can't have too much wind shear. We can't have too much dry air in place. So in other words, you need the ocean and the atmosphere working together in order to see a powerful hurricane like Ida. So what is wind shear? All right, let's put our eyes on that and get a better idea of it. So I've got a hypothetical, an imaginary hurricane here for you, if you will. So down at the ocean surface, let's pretend like our winds are blowing kind of east to west, blowing like this. So what is wind shear? Well, an example of wind shear would be if we have our winds down near the surface of the ocean blowing like this, but higher up in the sky, they're blowing in a completely different direction. That is wind shear, the wind direction changing as you get higher up in the sky. And if we get that, hurricanes don't like it. It starts to rip the storms apart and the hurricane weakens. So hopefully that gives you an idea of what wind shear is. Let's talk about hurricane names. Now, these behind me are the names we'll be using this year for the Atlantic hurricane season, tropical storms and hurricanes. So the list starts with Alex, Bonnie, Colin, so on. All right, so I want you boys and girls, take a minute, look at this list of names, and then do you notice any patterns? Let's look at it. First off, the one, when I show this to boys and girls in school talks, the one that most boys and girls notice is ABC order, right? Or alphabetical order. So every year, our hurricane names, the first name starts with A, second one with B, so on down the alphabet. Did you notice anything else? How about a hint? How many letters are in the alphabet, boys and girls? Do you know that? Do I hear a 26? Hopefully you said 26. Well, if you had time to count these up, we don't have 26 names. We have 21. Why is that? There are 5 letters we don't use. Q, U, X, Y, and Z. Why is that? Well, the people that came up with these names decided a long time ago they didn't think there were enough to choose from with Q, U, X, Y, and Z, so they left those off. And then the third final thing to note here is every year our names alternate either male, female, or female, male. So Alex this year would be male, Bonnie female, Colin male, and so on down the list. Now, twice in history, we've gone through that entire list of names. It happened in 2005, which was the year of Katrina, a bad storm in Louisiana, and it happened in 2020, which was a bad season overall, and that included Hurricane Laura that hit Louisiana. So the plan up through 2020 was when we ran out of names, we went on to something called the Greek alphabet. This behind me, that was names like Alpha, Beta, Gamma, and so on. All right, but there were a couple of problems. First off, look at this one, Zeta. We'd get down to Zeta and people start saying, uh-oh, we're through the Greek alphabet now, we're on to the Z name. Nope, that's not how it works. The Greek alphabet's a little bit different from ours. Our alphabet ends in Z. The Greek alphabet actually ends with omega, so people were getting confused by that. The other point of confusion for some people with the names with the Greek alphabet, listen to these names. Beta, Zeta, Eta, Theta, right? Do those sound pretty similar? So people were worried that those sounded too similar and were getting confused. So starting last year, we came up with a new backup plan, and that new backup plan, all it is to use more real world names, if you will, people names. So now these are the names that we will use if we ever go through that entire list of names that we use as our primary list of names. The other thing to note, those names get reused every 6 years. So our names this year in 2022 will come up again 2028, with the exception if a storm's really bad or it does a lot of damage, we retire that name. It means we'll never use it again. It gets replaced, okay? Now, this might be a little confusing, but I wanted to show you. This is when tropical storms and hurricanes most often occur. So you can see we start out going from June, July, August, September, and look at how we get a mountain here. Where do we get that mountain? From August into September and into like the first part of October. So most tropical storms and hurricanes, they're most likely from about the mid part of August through the mid part of October, with they're most frequent. They happen most often in about the first part of September. Now, as we look at that for Louisiana, I don't want to spend too much time on this. We've actually had a tropical storm impact us in May, and we've been impacted in November. But about 2/3 of our tropical storms and hurricanes occur in August and September really is far and away our busiest month. So just something to keep in mind as we make our way through hurricane season. August and September typically our busiest months and where we get some of our strongest storms. One last thing to show you guys before we wrap it up today. Now, if you watch as we track tropical storms and hurricanes this year on the news, you'll hear about something called the cone of uncertainty. Let's talk about how that cone is made, because I bet moms and dads watching this today won't even really know this is how it's made. So the forecasters at the National Hurricane Center, who forecast where they think hurricanes are going to go, what they do is they start out with where the storm is right now, and then they put a point on the map and they say, okay, well, this is where we think it's going to be 12 hours from now, 36 hours from now, 72 hours, 96 hours, 4 days from now, 5 days from now. It starts out with a dot. Then we draw circles around those dots. And for the moms and dads watching, the size of the circle is to represent the margin of error over the last 5 years in those hurricane forecasts, okay? Getting a little bit into the weeds, but they draw the circles around the dots and they connect the outside of those circles to make this cone. That's how the cone is drawn. The size of the cone does not change from storm to storm in a given hurricane season, okay? That's important. The size of the cone is not saying anything about how confident we are in the forecast for that particular storm. The size of the cone in a given season is about the forecast error over the last 5 years. All right, a little bit of a complicated subject, but I just wanted to point that out. One last thing with the cone, sometimes we focus a little too much on it because the impacts from a hurricane, you see our hurricane here, our imaginary hurricane and our imaginary cone. Look at how the hurricane, the clouds, the storms extend outside of the cone. So if you watch these maps through the hurricane season, just because the cone isn't necessarily over your town, over your city, over your community, does not mean you will not get impact. So be careful with that. All right, that's going to wrap up our hurricane lesson today. Hopefully you learned a little bit, boys and girls, and hopefully we get a quieter hurricane season. So with that, I'm going to hop on over and take a look now and see if you have any questions. So with the help of Mom and Dad, if you have any questions, pop them in the comments on Facebook. I got in a few in advance as well, and we'll roll through those. By the way, next week's lesson back here next Monday at 10 o'clock, we're going to talk all about clouds and the different types of clouds. And I've got a really cool experiment on how you can make a cloud at home. So be sure to check that out. But now let's go ahead and take some questions. All right, boys and girls, hopefully you enjoyed that lesson on hurricanes today. As I said at the beginning, we're in the hurricane season now. Still early. Things usually start to pick up a little bit later on, as we talked about. But now is the time. If you have any questions, if you need Mom or Dad to help out, go ahead and pop those in the comments in Facebook. Got a couple of questions while we were in the lesson. Deborah asked this question, and it's one we kind of hit on the lesson, but still a good one to ask. So Deborah said, why do some storms have the same names as previous ones? That's all because those storm names, they get reused every 6 years. So the list of names that we're using this year in 2022, they'll come up again in 2028. With the exception being if there's a storm that's really bad or it does a lot of damage, that name gets retired and it gets replaced. There's a committee that comes up with these names. It's with the World Meteorological Organization, and it's made up from representatives of a number of countries. And so they come up with the list and they vote on the names when a replacement is needed. So for instance, Ida has been retired. We will not have another Hurricane Ida. Laura, storms like that, Katrina, all those really bad storms you can think of. Generally speaking, those names have been retired. But if a storm, if we get one developing this year, it's not too bad. It'll come back up in 2028. Also had somebody asking about since we talked about hurricanes, typhoons, and cyclones all basically being the same thing, just called different things in different parts of the world. Had a question about where are tropical storms and hurricanes most common. They're actually most frequent, most common in the western North Pacific, so closer to Japan and China, places like that. That's where we can see sometimes upwards, we could see up to like 30 storms in a given season. Now we had that in 2020 in the Atlantic. We had a record-setting season, but typically over the long term, that's where they're most common, is in the western North Pacific. That's where on a global scale around the entire planet, that's where conditions are typically most favorable, not only to have the most storms, but that's usually where our strongest typhoons, as they're called in that part of the world, are. All right, I'll continue to take a glance down here for another minute or two, see if we have any other questions down. So I'm just taking a peek right now, see if we have any new questions rolling in. I will remind you that all these lessons are also available on our website once they're done, wafb.com/capscorner, on WAFB Plus if you're not watching there. Going to be on YouTube, I believe, as well. So you can check these out anytime. I did get this question from Monique. How long will the summer camp be going on? All right, so this was lesson number 2 today. We did an intro to weather last week, hurricanes today. We're going to have 6 more of these for the next 6 Mondays, every Monday at 10 a.m. I think that's through the first Monday of August, as I remember. So next week, we're going to talk all about clouds. All right, so is that interesting? I think it's pretty interesting. And what the kids might really like is I'm going to show you a really easy way to make a cloud at home. And I tell you what, when I do this demo, when I do this experiment at School Talks, the kids love it. So be sure to check that out. I do have another question rolling in. Aisha says, Isabella said, why do we have hurricanes? Okay, it's a good question. So for Isabella, one of the things that hurricanes do, we kind of think of them as people, that hurricanes are these really big and bad things, and they do a lot of damage. They can be really hard on people. We saw with Hurricane Ida that hit Louisiana last year. It did a lot of damage. It knocked some people out of their homes. But they do have a purpose in nature. In essence, what hurricanes are doing is kind of helping keep the planet balanced. They take warmth and moisture from closer to the equator and move it north towards the poles. At least in the northern hemisphere, move it north. Cyclones in the southern hemisphere kind of move it south. But our planet is very warm near the equator. Then as you go up to the poles, the north and south pole, it gets cold. And the earth is always trying to get this balance or trying to achieve some kind of balance. One thing hurricanes do is they kind of help give some of that balance by taking some of that where we have an excess, too much warm air, too much moisture, and send some of that away from the equator and up towards the poles. That's an important role they play, and that includes producing some rainfall sometimes in areas that need it. Now, sometimes hurricanes produce too much rainfall all at once. We know that all too well here in Louisiana, but they do have a purpose. There have been some experiments through time on trying to weaken hurricanes, and even some that have maybe had a little bit of modest success. I'm not a huge fan of messing with hurricanes and nature. So I think everything serves a purpose, even when they sometimes have bad consequences. So I think we need to be careful about that, but good question. All right, let's see if we have any others rolling in before we wrap it up here. All right, Aaron saying her son loved it. We have a notification set for next Monday. Good deal. And so great to watch it live because that's when I can take your questions live like we're doing here at the end. But let me show you quickly here that if you go to wafb.com/Caps Corner, we have everything there as well. So scrolling down a little bit, you can see we've got some links set up here, including to our YouTube page. And if you scroll down, you'll see that last week's lesson is now posted on their website. Why I'm about half invisible. Well, go watch it if you didn't go see it. I did a little demo on how we do weather in the studio. But what you'll also note is right above there, we've got some worksheets. So a couple, last week I've got a word search, and then just a little quick quiz about the lesson that we did last week. Should be later on today. We'll have a couple more worksheets about today's lesson about hurricanes. I've got another word search for the kids, another quick quiz that asks some of the questions about some of the basic points that we covered. But that can be found at wafb.com/Caps Corner. You can also see this is the third year we've done it. We've got the lessons from past years if you want to go back and watch some of those as well. Trying to mix it up this year. You're going to see some things that are the same, but the experiments we've done so far, those have been a little bit different, and trying to switch it up as much as we can. All right, I'm going to take one more peek down before we wrap it up. Oh, my friend Derek, I see you there. Derek asking your question about coming to visit. And let's see what else, if we have anything else. All right, it looks like we're going to wrap it up with that. I'm not seeing any other questions. Alvin saying we're Louisiana strong, no doubt. We've had to be Louisiana strong to get through these last couple of hurricane seasons. It's been rough, as we all know. All right, so with that, we'll go ahead and wrap it up. But hope to see you back here next Monday at 10 o'clock. We're going to talk all about clouds and have a really cool experiment for the kids to do at home. They can make a cloud just like that. See you then.